Okay, so in this video we're going to start our unit over force laws, and before we start talking about force laws, we're going to spend some time reviewing scientific notation. This unit is about the four fundamental forces in the universe: the gravitational force, the electric force, and the strong and weak nuclear forces. And those forces can be either really, really big or really, really small, depending on the distances involved. And so scientific notation is basically a way to very easily write very, very big or very, very small numbers. Okay, so you may already be familiar with scientific notation, but just in case, we will review. Okay, so here is basically how scientific notation works. When you have a number in scientific notation, the way you write it is you always have a decimal point. You always have exactly one number to the left of the decimal point. Let's say, I don't know, 1. And then you can have however many numbers you want to the right of the decimal point. So let's say I have 1.02. Let me rewrite that actually. Okay, so 1.02. Then that number is multiplied by 10 to some exponent. Okay, now the exponent can be positive or it can be negative. And depending on whether the exponent is positive or negative, depends on whether you're talking about a very big number or a very small number. If your starting number is greater than 1, you'll have a positive exponent. And if your starting number is smaller than 1, you will have a negative exponent. Here's what I mean by that. Let's say we have 1.02 times 10 to the power 2. Okay, so this is a number written in scientific notation. You always have one number to the left of the decimal point, and then it's multiplied by 10 to some power. If the exponent is positive, that means you have a number bigger than 1. 10 to the power 2, that is 10 squared, is 100. And if you multiply 100 by 1.02, you get 102. Notice that that is a big number. That is a number greater than 1. Okay, so positive exponent means that you have a number bigger than 1. And the 2 basically tells you how many numbers you need to move the decimal place. So for example, if you have 1.02, the fact that it's a positive exponent, so it's a positive 2, means you take this decimal place and you move it to the right 2 spaces. So 1, 2. And that would give you 102 and a decimal place, which is just 102. If your starting number is smaller than 1, you will have a negative exponent. For example, let's say I had 1.02 times 10 to the power negative 2. Okay, so 10 to the power negative 2 is basically 1/100th, and so that means that we have to move the decimal 2 spaces to the left. So the negative sign indicates that we move the decimal place to the left. So in other words, if we start off with 1.02, and we take that decimal and we move it to the left 2 spaces, we notice to the left because of the negative sign, we go here, and then here again. Okay, and so that means that there should be a 0 right here. So 0.0102, let me rewrite that, 0.0102 is the same as 1.02 times 10 to the negative 2. Now, what is the point of all this? Well, the idea is if you have a number that's very, very big or very, very small, you can save time by writing it in scientific notation. Okay, so for example, it's easier to write, let's say, 3 times 10 to the negative 6. That's a lot easier than writing 0.000003. Okay, it's a convenience matter. Okay, just like if we want to write 5 times 10 to the 9, that's way easier to write than 5,000,000,000,000. Okay, with 9 zeros. Okay, so scientific notation makes it easier to write a big number or a small number in shorthand. Okay, so what you need to pay attention to is number 1, the sign on the exponent. If you have a negative exponent in scientific notation, that means you have a number smaller than 1. That means you're going to have a small decimal number. And if you have a positive exponent, that means you have a large number, a number greater than 1. Okay? And the number, the actual number itself, tells you how many places to move the decimal point. So, type which of these numbers is the largest and which is the smallest based off of what we've just learned about scientific notation. So look at these 4 numbers here. Which of these numbers is going to be the biggest, and then which of these numbers is going to be the smallest? Okay, so the biggest is definitely going to be this one right here. You can tell because it has the largest positive exponent. Remember, positive exponent means big number. The number that is the smallest is going to be this one right here, the 1.9 times 10 to the negative 4. Negative exponent means a small number, and so the more negative it is, the smaller the number is. Okay, so pause there and make sure you understand writing numbers in scientific notation. Okay, so how do you convert from regular number to scientific notation? Okay, so let's say we have a big number and we want to write that in scientific notation. Okay, so what you do is you start with the number, the regular number that you want to convert into scientific notation. If it doesn't have a decimal place, just assume that the decimal point is at the end of the number. So let's say we have this number right here. This is 5,200,000. Okay, and let's say we want to write that in scientific notation because we know that'll be easier to write than 5,200,000. Okay, so we take our decimal point, and remember in scientific notation, you should only have one number to the left of the decimal point. In other words, if this is the number that we're trying to put into scientific notation, we want that decimal point to end up right here between the 5 and the 2. That way we only have one number to the left of the decimal. So now we need to count how many spaces do we need to move to get the decimal there. Okay, so 1, 2, 3, 4, 5, 6. We had to move 6 spaces, and because this is a big number, that means we should have a positive exponent. So in scientific notation, that would be 5.2 times 10 to the power 6. Notice how that's way easier to write than writing it all like this. Okay, positive exponent means a big number, bigger than 1. Negative exponent means a number smaller than 1. Do keep in mind, a negative exponent doesn't mean you have a negative number. It just means you have a number less than 1. Okay, so that means you have a small decimal number. Okay, so pause it there if you need to look at that some more. Okay, let's do another example. Let's say we want to take this number right here and we want to convert it into scientific notation. Okay, so see if you can figure this out on your own. Now, as far as how you type this out, the way we're going to type scientific notation is we're going to use the E symbol. In Canvas, you should be using a lowercase e, but on the calculator, you might sometimes see an uppercase E. This E represents times 10 to the power. Okay, so let me explain what this means. Let's say we have this number and we want to convert this to scientific notation. We know that the decimal place needs to end up so that we only have one number to the left of the decimal. So we have all these zeros. If we want one number to the left of the decimal, we want the decimal to end up right here. So let's count how many spaces that is. Here's where the decimal is. That's 1, 2, 3, 4, 5. Okay, so in scientific notation, this would be 3.14. We had to move 5 spaces. And the exponent should be negative because this is a number less than 1. This is a small number. Okay, so this is actually the answer. This is how you would write in scientific notation. In Canvas, what you would put is you would put 3.14 e negative 5. Okay, the e takes the place of times 10 to the power. Okay, so e negative 5 in Canvas is the same as times 10 to the negative 5. I don't know why Canvas requires it to be a lowercase e, because most of the time when you see this on a calculator, it's an uppercase e. Either way, if you put in uppercase E, it's going to get marked wrong by Canvas. That's not my my system. That's just the way Canvas works. So if you were doing a practice assignment or a test question, you would have to write it with a lowercase e and then -5. Okay, so in Canvas, writing 3.14 e -5 is the same as writing 3.14 times 10 to the -5, which is the same as writing this decimal right here. Okay, so pause there and make sure you understand how that works. Okay, and we've already done this, but let's say we want to go the other way. Let's say we want to go from scientific notation to regular notation. Remember that the the sign of the exponent tells you which way to move the decimal point. So if I have 6.22 times 10 to the power 9, this positive exponent means that I should move the decimal to the right 9 places. Okay, so 6.22, and then I go 1, 2, 3, 4, 5, 6, 7, 8, 9, and in all these places I should have a 0. Okay, so I end up with 6,220,000,000. Okay, it's much easier to write 6.22 times 10 to the power 9. Remember, scientific notation is just to make it easier to write big numbers or small numbers. Likewise, if I want to convert this number to regular notation, 7.011 times 10 to the -6, because this is a negative exponent, that means I should be moving the decimal to the left, and I should move it to the left 6 places. So here's the decimal. I go 1, 2, 3, 4, 5, 6. So that's 0, 0, 0, 0, 0. So that's 0.000007011. Okay, and again, notice that's much easier to write in scientific notation. Okay, so that's how you go back and forth from scientific notation to regular notation, and the other way as well. Okay, pause there, make sure you understand that. Okay, so for this example, I want you to take what we've learned so far, and I want you to put these numbers in order from the smallest number to the biggest number. Okay, so there's 5 numbers, A, B, C, D, and E. Put this in order from smallest to greatest. Okay, so hopefully you got that. The last thing we're going to talk about in this video is how to multiply and divide in scientific notation. Now, you might have one of these calculators, you might have a TI calculator, or you might be using an online calculator like Desmos. Okay, if you have one of these calculators, the double E function on the calculator is going to represent the scientific notation mode. Okay, so on the calculators I have in my classroom, for example, you would hit second, and then you would hit this double E that's in blue, and that would give you the scientific notation mode. Okay, so if I typed in 1.55 double E2, that would represent 1.55 times 10 to the power 2. Now, if you're using an online calculator like Desmos, for example, let's go to the Desmos calculator. That would be 1.55, and then you would do times 10 to the power 2. Okay, and you would do it just like that. Okay, the way you get that superscript there is you do Shift 6, and that gives you that exponent. Okay, so 1.55 times 10 to the power 2 is 155. Okay, it's really, really, really important that you understand how to type this into the calculator correctly. 9.11 times 10 to the -12. Again, if you're using one of my calculators or another TI calculator, you would just type in 9.11 second double E -12, and then hit enter. If you're using like Desmos, then you would do, what was that number? 9.11. You would do times 10 to the power -12. Okay, so make sure you understand how to type that into the calculator. Now, very, very, very important. When you're multiplying and dividing with numbers in scientific notation, make sure that you put parentheses around the entire number before you hit multiply or before you hit divide. Okay, let me give you an example. Let's say we want to do 4.5 times 10 to the power 6 divided by 1.5 times 10 to the power 6. Whether you do it in Desmos or whether you do it on a TI calculator, you would use parentheses around the top and the bottom. So I'm going to do parentheses 4.5 times 10 to the power 6. Oops, times 10 to the power 6. Divided by parentheses 1.5 times 10 to the power 6. Okay, the parentheses are really important. If you do that correctly, you should get 3. So whatever calculator you're using, try this calculation now. 4.5 times 10 to the power 6 divided by 1.5 times 10 to the power 6. Use parentheses, the number you should get is 3. Okay, and if you don't get 3, send me a message so I can help you out. Okay, so hopefully you got 3 there. Just to try one more quick example, let's try 9.2 times 10 to the power 3 times 2 times 10 to the power 1. And again, make sure you put parentheses around each thing that you're multiplying or dividing. Okay, so try that now. Okay, so here's what it should look like. Let's see. 9.2 times 10 to the power 3 parentheses times 2.0 times 10 to the power 1 parentheses. And you should get 184,000 if you type that in correctly. Okay, so either you're using the Desmos calculator or you're using another TI calculator. If you're using a TI calculator, that's fine, but you still need to put parentheses around each thing that you're multiplying and each thing that you're dividing. Okay, a lot of the calculations we're going to do in this unit involve multiplying and or dividing numbers in scientific notation, so it's really important that you understand how to do that correctly. Okay, so hopefully you got both of those answers. Okay, now you're going to be working on practice using scientific notation. As always, please let me know if you have any questions, and I'll see you guys in the next video.